Okay, so we are going to look at 7.1 linear equations with two variables. So I'm starting off with these two equations, and one of the elimination tricks that you can use whenever you have fractional coefficients is you go ahead and you multiply each and every single term by the common denominator over 1. That will go through and clear the fractions. So I'm going to go ahead and start by taking equation 1 and multiplying each term by 6 over 1. And then I'm going to go ahead and take equation 2 and do the same thing and multiply that also by the same common denominator. When I go through and do that, all of the fractions will go ahead and cancel out. All right, that's going to give me two new equations. So my first equation, when I go through and do that, 3 divides into 6 twice. The 6's equal 1, and 3 divides into 6 twice. So my new equation here is 2x plus y is equal to negative 4. And my next equation down here, 2 divides into 6 3 times. The 6 over 6 is equal to 1. And I am left with 3x minus y is equal to a negative 6. So I'm going to solve both of these algebraically now. Do know on an exam, if you're taking an exam for me, you would have to both give me an algebraic solution and a graphical solution. You get points for both. If you only have one, you would lose half the credit for that. So to give this through with an algebraic solution, I am looking at these two equations that I have in boxes, and I'm going to go ahead and line them up and put them right underneath each other. So I have 2x plus y is equal to negative 4, and 3x minus y is equal to negative 6. Now these equations already have opposite coefficients. So what I mean by opposite coefficients, opposite numbers are numbers that have the same value but different signs. So if I go through and look at this y has a positive 1 in front of it, and this y would be a negative 1. If that doesn't exist in that equation, you'd want to go ahead and multiply them through by a scalar, and go ahead and have an equation that has that. There'll be examples of that later. Now, I'm going to go ahead and start. Now, we're doing this because we're going to start talking about matrices and what we're doing with different lines. Please make sure that we understand that the notation, what I'm saying here. So I'm calling this equation 1, equation 2. So the notation here is I'm going to add equation 1 plus equation 2, and that's going to give me a new equation. When I do that, all I have here is 5x is equal to negative 10, and x is equal to negative 2. That's my first value in my solution. Because this equation has both an x and a y value, your solution will need to always be in the form of a point, x and y. That's my x value. Now I go through and find the matching y value. I can go through, and if I want to go ahead and plug that into equation 1 to find that, all that gives me is 2 times negative 2 plus y is equal to negative 4, which actually gives me negative 4 plus y is equal to negative 4. I know this one's a little weird because your solution for this actually just gives us that y is equal to 0. So that's my point. It's really important you write your answer as a point value, as x is negative 2 and 0 would be your final answer for this. Now I'm going to go through, and in the next slide, go ahead and graph both of the equations. Okay, as I said before, you do have to graph these as well. So the graphical solution for this, if we go ahead and look at equation 1. All right, so from the previous page, we had that equation 1 was equal to 2x plus y was equal to negative 4. So to graph that, I'm going to solve that for y, and I'm going to go ahead and get that y is equal to negative 2x minus 4. Now for the second equation that we had that was equation 2, and if we solve equation 2 by moving y over, we end up getting, actually let me go ahead and do it. It is 3x minus y is equal to a negative 6. So when I move that x over, I have negative y is equal to negative 3x minus 6, which changes all of the signs there, and I get y is equal to 3x minus 6. Now I'm going to graph both of these with slope and y-intercept. We'll go ahead and start with equation 1. Equation 1, I see that I have a y-intercept of a negative 4. So it gives me a point here. And then I know that the slope is negative 2. So I'm going to go ahead and go down 2 and over 1. It's also helpful to go ahead and look at this and see what the x-intercept would be. Whenever you are doing these for the x-intercepts, I do want them, the x and y, labeled. So to find the x-intercept, which you let is y is equal to 0. And if I solve that for x, I get x is equal to negative 2. And we're going to go ahead and graph that. Now, let's go ahead and do the second example. Equation 2, we're going to do the same thing. This has a y-intercept. Oops. Let me fix this real quick. That should have actually been a positive 6 when I went through and changed all of those signs. Sorry about that. So equation 2 will go ahead and be up here at x is 0, y is 6. And if I want to do the same thing down here and find my x-intercept, that just means solve for when 0 is equal to 3x plus 6. And you can, again, get x is equal to negative 2. Now, the other reason why I solved, so I'll go ahead and draw that line in. Now, the other reason I wanted to make sure I did the x-intercept for both of them is this is the graph of that solution. We said that our solution for both of those was negative 2, 0. And the solution for systems of equations are where those two graphs meet. Okay, so now we're going to go on to the special cases. Now, if we go back and we go through and put these equations in. All right, so I have 5x minus 2y is equal to 7 and 15x minus 6y. So to talk about what I was talking about before, the idea of the... All right, so let's talk about what an opposite coefficient is. All right, so opposite coefficients, what that means is that whatever is in front of the x value, they are the same number but opposite signs. So if I want to go through and turn these x's into opposite coefficients, what I would want to do with this is go ahead and multiply this through by a negative 3. Now when I do that, that'll give me a new equation. So that new equation would be negative 15x plus 6y is equal to a negative 21. If I take that down, let's go ahead and call this one equation 2. And bring equation 2 right down as it was before. You're going to see something with this. So this now means I have a positive 15x minus 6y is equal to 2. Now what I have here is I actually have two sets of opposite coefficients. Those coefficients are opposite. One is a positive 15, one is a negative. These 6's are opposite. Now what happens when I go through and I add these two together and add together equation 2 plus, if I want to call this my equation 1, this would be my new equation 3. And I add those two pieces together, this is going to cancel. And I'm going to get 0 plus 0 is equal to a negative 19. 0 can never equal negative 19. So what happens here is there is no solution. If I look more carefully at these two pieces, what you will find is that we have parallel lines. And parallel lines never meet. All right, so then this type of an equation is called inconsistent. This type of an equation is called an inconsistent equation because it has no solutions. All right, the second type of problem that we're going to talk about is one that looks like this. X minus 2y is equal to 2, and 3x minus 6y is equal to 6. So if we go through and start, again, the idea is we want to go ahead and turn these into opposite coefficients. So I want to go ahead and multiply this equation 1 times negative 3. When I do that, my new equation here would be negative 3x plus 6y is equal to negative 6. Now, this one is special because if you look at this, what happens when you add these two together? Everything equals 0. So these two equations are scalar multiples of each other, and since 0 is always equal to 0, what you basically have is one line being graphed right on top of that second line. So what we do in this case is we solve the line for y so that we can write the question as an ordered pair. So it doesn't matter which one of these equations you take because they are exactly the same thing. So I'm going to start with my first one, which was x minus 2y is equal to 2. I go ahead and solve that line for y, and I will write it as an ordered pair. Instead of x and y, after I find the solution for y, I'll replace that back in. So then I go ahead and move the x over. Negative 2y is equal to negative x plus 2. I divide everything through by a negative 2 here, and I am left with y is equal to x over 2. And again, I divided everything through by negative 2, so that's going to turn that into minus 1 right here. Now, what I mean by solving for this equation, I'm taking what y is equal to and replacing it back in over here. So now I'm left with my solution is x, my independent variable, so it stays as x. Y is my dependent variable, so it's x over 2 minus 1. And that would be your solution for here.